Now in this video we want to talk about how we can find the area of oblique triangles. Now oblique is just a fancy way for saying that a triangle is not a right triangle. Here I have a picture of a right triangle, and we can easily find the area of this triangle by multiplying 1/2 times the base times the height. But how can we find the area of a non-right triangle? Now in trigonometry, we can take advantage of a law called the law of sines, and it can help us find the area K of a non-right triangle. Here I have a triangle labeled ABC, and then we have the sides ABC, and these sides are labeled based on the angle that's opposite the side. So the formula for finding the area of triangles are 3. So we have K is equal to 1/2 times BC times sine of A. K is equal to 1/2 times AC times sine of B. And K is equal to 1/2 times AB times sine of C. And the way we know which formula to use is by which angle we are given in the problem. So let's look at an example where we can find the area of a non-right triangle. Here we have a triangle ABC, and the sides are labeled ABC, and we have the length of sides of 2 of our sides in the triangle. Side B is 5 feet, and side C is 10 feet, and we have the measure of angle A. So we can use the formula K, which stands for the area, is equal to 1/2 times B times C times the sine of A. So now we can substitute the information we have into the formula. So we already have 1/2, which is a part of our formula. B is equal to 5, that goes here. C is equal to 10. And then we have sine of 31 degrees. And when we put this in our calculator, we find that the area of this triangle is 12.9 feet squared. Now here is another example of finding the area of a non-right triangle. In this triangle, we are given the measure of angle C, and we have the measure of side A, which is 6 centimeters, and we have the measure of side B, which is 8 centimeters. And so we'll use the formula K, the area, is equal to 1/2 times A times B times sine of C. So now we just substitute in the information that we have. So we have 1/2 times 6, which is the measure of A, times 8, which is the measure of B, times sine of 51, which is the measure of angle C. And so we find that the area of this triangle is 18.7 centimeters squared. Now we can use the law of sines to help us find the measure of angles and the lengths of sides of non-right triangles. And the kinds of triangles that we can use the law of sine for are angle side angle, where we are given the measure of 2 angles and the length of a side in between those angles. Or if we're given the length of a side and the measure of 2 subsequent angles, or if we have 2 sides and a subsequent angle. So the ratios that we use for the law of sines are here. We have the sine of A divided by A is equal to the sine of B divided by B is equal to the sine of C divided by C. Sine of A, sine of B, and sine of C represent the measures of angles of the triangle, and A, B, and C represent the sides of the triangle. So here is a problem where we want to find one of the sides of this triangle. Now we can use the angle side angle to justify our use of the law of sines for this problem because we are given the measure of two angles and then the length of a side in between those two angles. So since we have the measure of angle C and the length of side C, and we also have the measure of angle B, but we don't have the length of side B, we can set up this ratio of sine of B divided by B is equal to sine of C divided by C. So now we can just substitute in the information that we have. We know the measure of angle B is 60 degrees, so we write sine of 60 divided by B. And we also have the measure of angle C, which is 45 degrees, so we'll write sine of 45 degrees here in the numerator. And we also have the length of side C, which is 340, so that goes here. Now we'll just use some algebra to help us isolate B and solve for B. So in this next step, we multiply both sides of the equation by b to get b out of the denominator. So in our next step, we see that we have sine of 60 degrees is equal to b times sine of 45 degrees divided by 340. And in this next step, we want to get b by itself, so we multiply both sides of the equation by 340 divided by sine of 45 degrees. So sine of 45 degrees and 340 cancel out and leave b on the right side by itself. And then on the left side of the equation, we have 340 times sine of 60 degrees divided by sine of 45 degrees. And when we put this in our calculator, we find that the length of side B is 416. Let's talk about the law of cosines. We can use the law of cosines when we are given side angle side information about a triangle. That means we are given the lengths of two sides of a triangle and the measure of an angle in between those two sides. Or we can use the law of cosines when we are given the measures of all three sides of the triangle, that is side, side, side. Now the formulas for using the law of cosines are these. We have a squared is equal to b squared plus c squared minus 2bc times cosine of a. The next formula is b squared is equal to a squared plus c squared minus 2ac times cosine of b. And the last formula is c squared is equal to a squared plus b squared minus 2ab times cosine of c. Now here we have a triangle where we are given the lengths of three sides of the triangle. And we want to find the measure of angle C. So we'll use this last formula to help us find the measure of angle C. So substituting in the information that we have into this formula, we write 12 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of C. 12 squared equals 144, 5 squared equals 25, and 8 squared equals 64. 2 times 5 times 8 equals 80, and then we have cosine of C. Now when we add 25 and 64 together, we get 89. On this line, we subtract 89 from both sides of the equation. So on the left side of the equation, we have 55 and equals minus 80 times cosine of C. Now we want to get cosine of C by itself, so we'll divide both sides by negative 80. So the result is, on the left side of the equation, we have 55 divided by negative 80 equals cosine of C. Now we want to get C by itself, So we apply inverse of cosine to both sides of the equation. Inverse of cosine will cancel out cosine, leaving c by itself. So when we put inverse of cosine of 55 divided by negative 80, we find that the measure of our angle C is 133.4